हेलो एवरीवन। आज हमारा लेक्चर विल बी ऑन इनवर्स ट्रिग्नोमेट्री एंड दैट विल बी cosec inverse. So we will discuss cosec inverse. In cosec inverse, we know that cosec x is equal to 1 upon sin x. So we have to find out what will be the domain and range of the cosec function. So in the denominator there is sin x. Sin x is not defined for values of x equal to 0 for angle 0, plus minus 5, plus minus 2 pi, plus minus 3 pi. So where sin x is equal to 0, these values when something in the denominator, it will be infinite. So sin x equal to 0, then x will be 0 plus pi minus pi plus minus pi comma plus minus 2 pi and so on. For these values sin x will be 0, and if sin x will be 0, then cos x will not be defined, because something upon 0 will be infinite not the real numbers. So in these value, for these values our cosec x will not be defined. So from the domain we have to export these real numbers. So domain of cosec x will be, domain of cosec x will be x such that x cannot be n pi and all real number. Here x belong to the set of real number. So we have to delete from the set of real numbers. Set of real numbers is from minus infinite to plus infinite. For these values, for these angles, the cosec x will not be defined. Now next we have to find out the domain. What will be the domain of the cosec x? So here if I draw the graph of the cosec x, so x is the real number, particularly this will be set of integer. X is the set of integer. It will be, x will be the real number, but n will be the set of integer. N will be the set of integer. So this is our domain of the cosec x. So we have already deleted from the set of real number. X belong to real numbers and x cannot be n pi, multiples of pi, that is plus minus pi, plus minus 2 pi and so on. And there if n equal to 0, n is also 0, can be 0. 0 is the set of integer. Now 0 is the real numbers. Now here the range of cosec x, range of cosec x will be y such that y is the real number and y should be greater or equal to 1 and y should be less or equal to minus 1. So this will be the range of cosec x. Also we can say that it is also the codomain of the cosec x. So if I define the functions here, cosec is equal to, our domain will be this part. So here the domain, except these values of these ones, set of R, we have deleted x such that x is equal to n pi. We have deleted from the set of real numbers these numbers, multiples of pi. Here n is the set of integer and its range will be, Here range will be from the set of R, we have to delete from -1 to 1. So I have explained that here why greater than 1. The range element is either equal to 1, greater than 1, or less than 1, less or equal to -1. So we have to write here for or. Either at a time the values can be either greater than 1 or less than -1. So this is our range, and we have excluded in our range. We can write this like from the set of real numbers to delete the numbers -1 to 1. So it will be our range of the cosec-x, also known as codomain range. This is also the codomain. So this one will be domain and this will be our codomain. So now if I draw the graph of cosec-x, this is the x-axis and y-axis. Since the values of in the range part, the value we have deleted from -1 to 1 from the set of real number, and we also know that at 0 and plus minus pi, plus minus 2 pi, cosec-x will not be defined. So if I draw the graph for cosec-x, then it will be, so here and sine pi, we know sine pi, at sine pi cosec-x will be infinite, and at sine pi and cos 0 will be also not defined. So our graph will be will lies from infinite, it goes from infinite. This is like this one. So 0 to pi, first branches, first interval is from 0 to pi, and it goes up to the 1. Starting from 1 goes to infinite, and next branches we have between pi and 2 pi. So we know that cosec 0 to pi is first and second quadrant, first and second quadrant. This is our first quadrant, second quadrant. First and second quadrants, cosec-x will be positive. That's why it goes from 1 to infinite. In the second and third quadrant, so we know that this is a first quadrant, second quadrant, and this is the third quadrant. This will be the fourth quadrant. So these are the quadrant, and in first and second, sine and cosec will be positive, and the third and fourth it will be negative. So we have to draw the graph for from pi to pi. In the third and fourth quadrant, the angles will be, this is pi and this is 2 pi. So from pi to 2 pi, it means that in this part, so we have drawing the graph for this part. In this part, cosec-x will be negative. So this is a minimum values will be -1, so it will goes from -1 to minus infinite. Now that's why the graph of this one will be, and so on. It goes from, this is the -1 to minus infinite. So here +1 to, in first two quadrant it is goes from first quadrant to infinite. This is the infinite, and along this one is minus infinite. So this will the graph for the range part will be drawn in along y-axis, because y says that y should be either greater than 1 or greater than or less than -1. So or r we have to delete in the from the set of real numbers -1 to 1. This part will not be the part of the range. Now one more, again from 0 to minus pi. 0 to minus pi means along this one, 0 to minus pi. In 0 to minus pi it will be also negative portion. So this is x is equal to 0. This will be, if I goes clockwise, this is the clockwise, this will be x is equal to minus pi. So from 0 to minus pi, this is our y-axis, and this is our x-axis. So if I take the angles clockwise, it will be negative. So from 0 to pi, again we come in the third and fourth quadrant. This is the third quadrant, and we already know third and fourth quadrants. Cosec x will be negative. So again the graph will be, should goes from here like this. This is the graph. So it goes up to the -1, from -1 to infinite, from -1 to minus infinite. So along this one is minus infinite, along this one be plus infinite. So in these portions we have seen that, the graph of the cosec x will not be included between -1 to +1. So this is the portion. The lowest one along the positive side is +1, and highest in the negative side is -1. From -1 to minus infinite, +1 to plus infinite. This is the graph of the y is equal to cosec x. This is the graph of cosec x. Cosec x. So we have seen that this graph is not 1 it is many one type of graph. If I restrict the graph from some interval, then it will be 1 and on 2. So we have taken the intervals. We have taken the interval from pi to 2 pi, 0 to pi, and minus pi to pi, and minus 2 pi to minus pi. These would be the interval. So same if I draw the graph between minus pi and 2 pi. Minus pi and 2 pi will be again angle should be clockwise. So here is minus pi, again this will be x is equal to minus 2 pi. If I goes clockwise, so from minus pi to minus 2 pi, it will be cosec x will be positive. So this is first and second quadrant. This is minus pi, this is minus 2 pi. So we are going there, taking the angles clockwise. If I take the angles clockwise, then our graph will be again here the lowest value will be here +1, and highest will be plus infinite. The graph of cosec x between minus 2 pi and pi will be so in the graph, in the range -1 to 1, these real numbers will not be included. So that's why I have deleted from the set of real numbers the interval -1 to 1. So R is the set of real number. Set of real number. So now if I consider the domains here -2 pi to pi, from -2 pi to -2 pi to minus pi, and second interval minus pi to 0, third intervals 0 to pi, and next one pi to 2 pi, and so on and so on. So in this graph, if I replace the domain of this one, domain cosec domain of this one, if I replace the domain of this ones, our range will be again R to -1. Our range will be again same one. So in this case the functions will be 1 1 1 2. 1 1 and 1 2. If you take the domain this one, either this one, and so on, all have the same range. Range will be this set. From the set of real numbers we have deleted -1 to 1. So here these are the intervals -2 pi to minus pi to 0, 0 to pi, and pi to pi. Here like -2 pi to minus pi, and the values of cosec x goes from 1 to infinite, and similarly from minus pi to 0 it is -1 to minus infinite. So in this case it will be 1 1 type of functions. and 1 1 and into function. It will not be onto functions, because in that case if I consider only this interval minus 2 pi to minus pi, only the values of real numbers will be in the our range part from 1 to plus infinite, but the real numbers from minus 1 to minus infinite will not be in the range part. For making it 1 1 and onto functions, we have to consider the whole range of the cosec functions. For considering the whole ranges, we have to mixed up two intervals which is side by side, like taken these two interval consecutive intervals. If I consider these two consecutive intervals or these two consecutive intervals and so on, it will be then our range will be this one from r to r minus this interval minus 1 to 1. So we have to consider to mixed up two consecutive bracket of these ones. So like minus this will be minus 3 pi by 2, minus 3 pi by 2 to minus pi by 2, minus pi by 2 to plus pi by 2. So if I indicate this one, this will be pi by 2, this value is pi by 2, and this value minus pi by 2, and it will be 3 pi by 2. And if I consider from like minus 1 intervals minus pi by 2 to pi by 2, so it will contain all positive and real numbers, and minus pi by 2 to 0, the range element will be from minus 1 to minus infinite, and from 0 to pi by 2 it will be from plus 1 to plus infinite. So making the intervals for 1 1 and 2, we have mixed up two consecutive these such type of intervals. Now the intervals, if I take the intervals from minus 3 pi by 2 to minus pi by 2, and next one minus pi by 2 to plus pi by 2, and next one pi by 2 to 3 pi by 2, and so on. On these branches, our range will be, all these intervals should have the range, same range. This will be our range, and the functions will be in that case 1 1 on 2, and function will be 1 1 and on 2. So 1 1 on 2 is also called bijective function. This is called the bijective functions. So let us take one branch of this one, cosec-x. If I consider this branch minus pi by 2, minus pi by 2 to pi by 2, and our range will be, this is our range. So this is our domain, this will be our range. This range is also the codomain. Always range is the subset of the codomain. So here from minus pi by 2 to pi by 2, so it includes all the element of this set. It means that from minus infinite to minus 1 and 1 to plus infinite. So in this part will be from this is plus 1, from plus 1 to goes to infinite 1, and from minus 1 to minus infinite. So this is plus infinite, this is this, in this side is minus infinite, and the real numbers not included, which is lies between minus 1 to plus 1. So in this way, if you consider other branches also, this is our minus 3 pi by 2. This real number is minus 3 pi by 2 to this one. Again, if I consider the range from here to here, minus 3 pi to minus pi by 2. It means that from here to here, this portion, and this portion also. So in these branches, if I take these branches, and our range will be same one, and same way if I take the branches from pi by 2 to 3 pi by 2, our range interval will be from 1 to plus infinite and minus 1 to minus infinite. So we just consider only this one, minus pi by 2, pi by 2. Later we call this one's principal value branch of the cosec inverse. So next we discuss the inverse of the cosec-x. Now this is the curve for y is equal to sine inverse x. Sorry, it is y is equal to cosec inverse x. And this graph is already y is equal to cosec x, corresponding if I interchange x axis and y axis, we get the graph for the cosec inverse x. So here we have to restrict our graph between the intervals where cosec x is 1 1 on 2 functions. These intervals we already discussed, and cosec inverse, that this is a plus 1, this will be minus 1, plus 1 minus 1, this is pi by 2, pi by 2, this is pi, this is 3 pi, 3 pi upon 2, and this will be 2 pi. And same way here, this is minus pi by 2, this is plus 1, minus 1, minus pi by 2, and it will be minus 3 pi by 2, and it will be minus 2 pi. And now corresponding graph of this one will be so corresponding graph of this one in cosec x will be this one. Here our cosec inverse will define its range will be not range, its domain will be this intervals, which is the range of the cosec x, and corresponding interval, if I consider only minus pi by 2, pi by 2, minus pi by 2 to pi by 2. Same way other intervals can be, and from if I this is our domain, and corresponding range will be this one. These functions will be 1 1 on 2 functions, and this is also known as the principal value branch of the cosec inverse. So corresponding graph of this ones will be this one, from 1 to plus infinite, and the values of the values of the domain is from 1 to plus infinite, and the values of the range will be from minus pi by 2 from minus pi by 2 to pi by 2, and corresponding graph of this one will be in the negative side of this one. Same way, if I consider the graph of the interval minus 3 pi by 2 to minus pi by 2, corresponding domain will be this one, minus 3 pi by 2 to minus pi by 2, here at minus pi by 2, between minus pi by 2 and pi by 2, there is some angle of 0. So we already know that y is equal to 1 upon cosec x is equal to 1 upon sin x, and sin x is not defined as 0 degree. So we have to exclude from the range 0 angles. So because at sin 0 degree, sin 0 degree will be 0 and 1 upon 0 will be infinite, and cosec x not defined at 0 degree. So same way in this case we have to exclude from the interval the angles minus pi, minus 3 pi by 2, minus pi by 2, minus pi. Now corresponding graph of this one will be, so here it will be from minus infinite, this side is minus infinite, it will go till minus 1, again go this side. So this is the graph corresponding the intervals minus pi to 0, and this is the graph for the interval 0 to pi. Now next one for the intervals of pi to 2 pi, this is for third and fourth quadrant. Cosec x will be negative, and it means that pi to 2 pi, this is third quadrant, our graph is negative. Corresponding graph in the cosec inverse will be this one. So this is the graph for this interval, and next we have we also draw the graph for minus 2 pi to minus pi. We'll have the graph minus 2 pi to minus pi again in the third and fourth quadrant. Third and fourth quadrant, cosec x will be negative. So corresponding cosec inverse will be here from minus pi to this interval. So this is the graph for this interval. So now all these portions for these subintervals, for these intervals, corresponding graph of the cosec inverse will be this ones. So if I restrict the graph for these intervals minus pi by 2, deleting this number, so then cosec inverse will be 1 1 on 2. Cosec inverse will be 1 1 on 2 functions. So all these two are the 1 1 and on 2 function. These will be 1 1 and on 2 function. And we just located the principal value branches. So these branches will be principal value branch of the cosec inverse. It means that if I consider this interval minus pi by 2, here if I consider the interval this one minus pi by 2 to pi by 2, deleting zeros from here, so it will be principal value branch of the cosec inverse. Branch of cosec inverse. So our main considerations will be in the numericals also. Principal value branches, if the branch is not given, we goes directly to the principal value branch. So this branch will be our principal value branch of the cosec inverse. I think it will be clear, sir, for all of you. So now again just some repetition, something uh, for considering the principal value branch, the domain of the minus pi by 2 to pi by 2 excluding to 0. So here minus pi by 2 to 0, I means that it's a graph only, graph of this portion and graph of this portion. So here will be here minus pi by 2 minus pi by 2 to plus pi by, this is minus pi by 2. It means that this graph, this portion and again this portion will be called the principal value branch of cosec inverse x. Corresponding here, corresponding part in the cosec x will be here, this one.